Okay, so in this video, let's look at exponents. You need to be familiar with exponents, sometimes called indices. It's important that you master this because you will use them a lot in manipulating equations and solving solving complex problems in mathematics. What is an exponent? So if we write a number as a to the n, we call a the base, and then n we call it the exponent or power or index. These three it mean the same thing. So when we have a to the n, a is the base, n is the exponent. Now there's also another term, exponentiation. What is it? This is essentially a repeated multiplication of a number by itself. Let me show you some example to clarify that further. 2 cube. 2 cube, you write it as 2 cube equals 2 times 2 times 2, which is equals to 8. And you can see that we multiply 2 by itself 3 times. Remember, 2 is this base right here, and 3 is the exponent. So you can see a to the n, you are multiplying a by itself n times here, and that's what you can see here. Let's look at another example. 10 raised to 6. This is equals to 10 times 10 times 10 times 10 times 10 times 10, which is equals to 1 million. Here we multiply 10 by itself six times. So more generally, a to the n is equals to a times dot dot a times a. So essentially, we are multiplying a by itself n times. In this case here, we assume that n is indeed a positive number, but n can also be negative. I will show you later on in that case, how we can handle negative cases. But for now, you can assume that n here is positive. In fact, n can also be a fraction. In fact, n can be a real number. Okay. Now let's go through some of the rules, and the very first one is the product of powers. The product of powers is, for example, a to the m times a to the n. This one is a this one is a power, and this one is a power, and the whole thing is a product because we are multiplying the two. And the rule says when the bases are the same, or when we're dealing with like bases, we essentially add the exponents. In this case, a to the m times a to the n is equals to a to the m plus n. Let's look at this example. 2 cubed times 3 raised to 4. Now, because the bases are the same, we add the exponent. So this becomes 2 raised to 3 plus 4, which is equal to 2 raised to 7. If you plug this into your calculator, you should get 128. We can check this using traditional methods by computing 2 cubed separately to get 8, and then computing 2 raised to 4 to get 16. Now, what is 8 times 16? Your calculator should also give you 128, which agrees with our first answer. Next one, we have quotient of powers. A quotient is a fancy word for a fraction. You can see this is a fraction. A to the m divided by a to the n. In that case, since the bases are the same, the rule says you just subtract the exponents, or I should be more clear. You subtract the exponent from the denominator. You subtract that from the exponent of the numerator. In this case, a to the m over a to the n is equals to a raised to m minus n. Okay, let's look at an example. 3 raised to 5 divided by 3 squared is equals to 3. Now I subtract this 2 from 5, so it becomes 3 raised to 5 minus 2, which is equivalent to 3 cube, and which is equals to 27. We can check this by computing directly the numbers. So 3 raised to 5 will give you 243. 3 squared will give you 9. If we divide 243 by 9, you should also get 27. What about a power of a power? So in this case here, a to the m is a power, but we're raising it to another power n. So I hope you can see that. It's a to the m raised to n. In this case here, the rule says that we can just multiply the exponents. So it becomes a to the m raised to n is equals to a raised to m times n. The dot here is a shorthand notation for multiplication. You will see that a lot, so please take note of that. Okay. Let's check this with an example. 4 squared raised to 3. What does the rule say? The rule says we multiply the exponents. So in this case here we have 4 raised to 2 times 3. And 2 times 3 will give you 6. So now 4 raised to 6 will give you 4,096. Now let's compute it using a traditional method. You see that we can compute the bracket first. So 4 squared, when we compute that, we get 16. And then now we raise 16 to 3. And when you plug that into your calculator, you should also get 4,096. Product of a product. So product of a product. In this case here, power of product. So A and B. Remember the dot. The dot is a product, or is a multiplication. In this case here, A and B, these are two numbers that you are multiplying, and you're raising them to m. So the rule says you basically just distribute the exponent inside the brackets or inside the parentheses. In this case here, a times b raised to m becomes a raised to m times b raised to m. And let's look at a practical example. 2 times 3 raised to 4 is equals to, we distribute the 4, the exponent, it becomes 2 raised to 4 times 3 raised to 4. And then we can compute 2 raised to 4 to get 16. And then we compute 3 raised to 4 to get 81. Now 16 times 81 is equals to 1,296. Of course, you can compute this directly by just computing the bracket first. So 2 times 3, that will give you 6. Now what is 6 raised to 4? That should also give you 1,296. Okay, now what about the power of a quotient? Remember, quotient is a fraction. If we are raising a fraction to some power, you also distribute the exponent. You distribute the exponent to both the numerator and the denominator. Let's look at an example. 2 over 3 raised to 3. So we distribute the 3, so we get 2 cubed divided by 3 cubed. Now 2 cubed will give you 8 on the numerator, and the denominator we have 3 cubed. That will give you 27. Now, I guess there's no need to check this one. It's fairly obvious. Okay, now let's go to special cases, and we start with the 0 exponent. You've probably heard before that any number raised to 0 equals 1, but there's a caveat. So the base cannot be 0. In fact, When a equals 0, this is undefined in mathematics. So please take note of that. Okay? Yeah. Let's go through some examples. We have 5 raised to 0 equals 1. 1 million raised to 0 equals 1. Minus 2.89 raised to 0 equals 1. Pi raised to 0 equals 1. So I don't care what number you give me. As long as it is non-zero, if I raise it to 0, I get 1. So that's the thing you need to take away from that. And note what I have down here. Minus 2.89 raised to 0 is not equals to 1. I see this a lot even in college level mathematics courses when I'm correcting papers for students. Please don't make this rookie mistake. It can cost you dearly. Remember, this one I have right here is not the same as this one right here. In here, I'm raising everything inside the bracket to 0. In fact, there's a minus 1 hiding inside here. Minus 1 times 2.89. In fact, I'm raising minus 1 to 0, and I'm also raising 2.89 to 0. That's not the case here. In here, I'm only raising 2.89 to 0, which is equals to 1, but there's a minus 1 hiding beside it. That's why this is not equal. In fact, minus 2.89 raised to 0 is equals to minus 1. So that's the correct answer. Okay. The next special case is a negative exponent. I alluded to this in the beginning. When we have two numbers, if we multiply two numbers together and we get 1, so we say that those two numbers are reciprocals of each other. For example, 5 and 1 over 5. Those are reciprocals of each other. So that's essentially what's happening here. A raised to minus n, when you have a negative exponent like this, you can take it downstairs and then you lose the negative sign. Similarly, if you have a fraction like this, 1 over b raised to m, you can take it upstairs, but then you have to introduce a minus sign, or you have to gain a minus sign. I cannot emphasize how important this rule is. You can use it to simplify really complicated problems. Okay, yeah, I just said that this indicated a reciprocal. Well, let's look at this example. 3 raised to minus 2. You take it downstairs, you lose the minus sign. It becomes 1 over 3 squared, which is 1 over 9. Implication. This is my favorite so far of all the stuff we've seen. Notice how we can, here I have a fraction a over b, or a quotient a over b raised to m. And notice how I can just flip the fraction and then negate the exponent. Trust me, if you take more math courses, you'll find this rule really useful, because it will help you simplify really complicated problems. Because when you do this, if you can do this in an equation, sometimes you see that stuff just cancel, and that's why you see sometimes some students they'll be scratching their heads because they cannot see a way to solve a problem. But turns out, maybe you just need to do something like this, and then all of a sudden things cancel, and you now dealing with a much simpler problem. Okay. So I have an example here. For example, 2/3. So 2/3, you based on the rules of quotient we've seen, you distribute the 2. So you get 2 squared divided by 3 squared. And 2 squared is 4, 3 squared is 9. So basically this fraction here becomes 4 over 9. Similarly, I can use this implication here to flip the fraction. In this case, it becomes 3 over 2. And then I negate the exponent. Remember, it was a 2 here, now we have minus 2. And then we use the same rule. We distribute the exponent. So this becomes 3 raised to minus 2 divided by 2 raised to minus 2. Now 3 raised to minus 2 equals 1/9. We've already seen it here. Okay? And then 2 raised to minus 2 is 1/4. And 1/9 divided by 1/4 is 4/9, which is what the same as what we've seen here. So essentially, there's nothing illegal we're doing here. Or I should say, this is a numerical way of showing that what we're doing here is essentially correct. Okay, so the next case is a fractional exponent. When I say fractional, I mean the exponent is indeed a fraction. You can see here already in the definition m over n, so that's a fraction. Just know that n cannot be 0 because we do not want to divide by 0. And notice that the n here, the lower number, is the root. It's basically the same as taking the root, the nth root in this case, the nth root of that number. There are two ways you can express this. First, you can you can exponentiate the base a to m, which is what I did here. So the first thing I did is I exponentiate a to m, and then I take the nth root. I take the nth root of whatever I get. Or I can take the nth root of a first. I can take the nth root of the base, and then whatever I get after, I exponentiate it to m. So those are the same thing. So yeah, so in this case here, a raised to m over n means taking the nth root of a raised to the m's power. Let's do some examples. 8 raised to 2/3. So using this method right here, I first exponentiate 8. So I raise 8 to 2, so 8 squared. And then I take the cube root of 8, of whatever I get. In this case here, 8 squared gives me 64. And then I take the cube root of 64 to get 4. So there's a caveat though. When the base is a negative number and n is an even number, we end up with what we call a complex number. I will not talk about complex numbers in this video, but I thought you should be aware of that. So in here I said a less than 0, which means a is negative and it's even. So in that case, yes. Let me show you a simple example. If we have a equals -4 and n equals 2, and then we can write a raised to 1 over n as -4 raised to 1/2, which is the same as taking the square root of -4. Remember, this number below here is the root. Okay, so in here this is the root, nth root. Because here n equals 2, this is the square root. If this was 4, that would be the fourth root. If n was 3, that would be the cube root. Okay, so now we're taking the square root of -4. So that's already a negative number. We're taking the square root of a negative number, and so that'll give you plus or minus 2i, where I is defined as the square root of -1. Okay, so that's what I'm trying to say here. So this is a complex number. Oh, that's what I was calling a complex number. Okay. Yeah, so we've seen a lot, and this is a summary of everything we've seen so far. The very first case here deals with the same base. In this case here, product of powers, a to the m times a to the n. You can just add exponent, so that becomes a to the m plus n. If you have a quotient, you subtract. A raised to m divided by a raised to n equals a to the m minus n. If it is the power of power, a to the m raised to n, It's equal to a to the m times n. You multiply the exponent. Now, when the bases are different, for example, here we have a product of a power of a product. So a to the a times b raised to m. We distribute the exponent. It becomes a to the m times b to the m. A quotient, the same. You distribute again. A over b raised to m is equal to a to the m divided by b raised to m. And then the special cases we've seen so far, zero exponent, anything raised to 0 equals 1 as long as a is not equal to 0. Negative exponent, you take it downstairs, you lose the minus sign. Implied reciprocal rule, you can flip a fraction, a over b raised to m, as b over a, as long as you multiply the exponent by minus 1. And then the fractional exponent, you can take the root, or you can exponentiate. You can exponentiate the base to the numerator, and then take the nth root, or take the root, which is the denominator. So the denominator gives you the root. Okay. So these are essentially the exponent or the exponential laws you need to know to be prepared for college level mathematics courses. Okay, try to do some examples, and they become very intuitive fairly fast. Okay, thank you for watching.